Okay, so when you have two lines on the same graph like you just did on your Desmos activity, we call that a system. So a system of equations is made up of two or more equations on that same graph. Now graphically, that means if you're looking at it on Desmos, your solution is where? On Desmos, when I graphed both of those lines, where was our answer, Macy?
Where the two lines cross.
Where the two lines cross. So where the two lines cross or where the two lines intersect. I don't care what word you use because they mean the same thing. Now algebraically, that means by hand, the ordered pair that was your solution to your graph is going to be the x and y value that makes both equations true. So quickly, for an example, an easy one that we had, was the sum was 6, but the difference was also 6. Do you guys remember that one? So you had x plus y equals 6, and you also had x minus y equals 6. Do you remember what the answer to that was? 6, 0. So I'll show you what it means by algebraically. That means when you plug and chug your x and your y, it's going to work for both equations. So if I do 6 plus 0, what do I get? 6. And does 6 equal 6? Is that true? Yes. So it works for the top one. Now I got to do it on the bottom one. Does 6 minus 6 give me 6? 6? Oh, don't listen to what I said. Does 6 minus 0 give me 6?
Yes.
Yes, it helps if I say it correctly, right? So 6 does equal 6, and it works for both. So this is algebraically, when you plug in the same ordered pair, it's true for both equations, not just one, okay? So we've talked about on Desmos, when you have intersecting lines, how many answers do you have? 1. It's just where they cross, right? So it's that one intersection point, and you write it as an ordered pair, an x and a y. Don't forget your parentheses. Every year I have the lazy kids not put parentheses around their numbers. Please do that for me. But two other types of solutions that we didn't talk about were parallel lines and the same line. So parallel lines, are parallel lines ever going to intersect?
No.
So do they ever have any points in common? So how many solutions are they going to have if they don't have any points in common? None. No solution. It's not possible for parallel lines to share a point, so nothing. What if you have two lines, but they're the exact same? So you graph one on Desmos, it looks like this. You graph the second on Desmos, and it plops right over top. I like to show this by just kind of doing a little dotted line, showing that there's 2 points or 2 lines right on top of each other. So if there are 2 lines right on top of each other, how many points do they have that are the same? All of them. How many points are on a line? A lot. So what do we call this? Infinite solution. Any single point that is on either of those lines, since it's the same, will work as a solution. So infinite solution. Okay. So first we're going to start with graphing, and we're going to use Desmos to help us. So if I give you the system, it normally looks like this, just 2 equations of lines. We're going to graph them first. This one's in slope-intercept form, so could we do this one by yourself? Yeah, so let's just do this one quickly. We'll do the others with Desmos. Where do I start if I want to do y equals x minus 8? Negative 8 on which axis? Y. So drop down 1, 2, 3, 4, 5, 6, 7, 8. Draw a point there. And if my slope is 1, that means up 1 over 1. And try to do as many points as you can. It'll help you find your answer once you graph your second line. So I know it's tedious in the moment, but I promise it's helpful. Now my second line, I'm going to use a different color. Where do I start on my y-axis? 1. And if I have a slope of negative 2, if I start and I go down 2 first, do I go to the right or to the left one? To the right. Remember, only one number is negative. If you do two negative numbers, you accidentally made it a positive, and you don't want that. But this right here is why I like to use Desmos anyways, because some of you guys mess up your negative slopes, and with Desmos, it's not going to mess it up. Okay. Hopefully, when you are drawing all those points for both of those lines, you maybe mapped the same point twice, right? Or hopefully we did. If you did it correctly. If you didn't touch the same point twice, maybe we have one of ours wrong. Okay? Where do those 2 points cross? Where do they intersect each other? Macy?
3, -5.
3, -5, and I'll count it to be sure. 1, 2, 3, down 1, 2, 3, 4, 5. That's where mine is too. Perfect. Okay. We're going to check this in Desmos just in case. So go ahead and type both of those into line 1 and line 2. And click where they cross each other. Does Desmos tell you 3, -5? Yeah, so I like graphing it on Desmos better for 2 reasons. One, it's not going to make a mistake graphing your lines, period, whether it's negative slopes, positive slopes, anything. And 2, you can literally just click your ordered pair. Some of you guys do -5 first and +3 second, so it kind of helps with those small little mistakes. Does that make sense? Okay, so for the second one, number 2, are these equations in slope-intercept form? No, but if I look at them, I have taught you how to convert them into y = mx + b. What would I have to do for that top equation to convert it?
Subtract the 3x.
Just add the 3x over, and I wouldn't even need to divide because there's nothing in front of the y, right? So it wouldn't be that hard to do it by hand, but we're just going to use Desmos anyways. Is that okay? All right. When you use Desmos, the part that I like is you don't have to convert. You can leave it exactly as it looks on your paper. So I'm just going to do -3x plus y. Even though I know how to change it, I'm not going to risk making any mistakes on my end. Line 2, same thing. Just leave it as it is. -x plus y equals -2. Now, the only time Desmos makes a mistake is if you make a mistake. So it's really important that you get all your negatives in there if they're on your equation, and you correctly put in your plus and minus. As long as it looks exactly as it does on your paper, you're good. But if you make a mistake, so does Desmos. All right, so if I'm looking at this picture here, where's my solution?
-5, -7.
Plot that on your graph first. -5, -7. -1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right there. Now, since we use Desmos to graph it, I'm just going to have you do a rough sketch in your notes. So I want you to find 1 or 2 more points to help you draw your line. I'm going to start with the purple line. Do you see any other points that are nice, pretty points to help us graph? Click on them. What do you get?
-6.
I just clicked on my X and Y intercept, so you could maybe use other ones if you wanted, but I just used the 2 that popped up for me. So 0, -2, I'm going to plot it, and +2, 0, I'm going to plot it. That's enough. It's just a sketch for your notes. Desmos gives you exactly what you need. So I'm just going to draw a rough line for that second line. And then for my green one, your x-intercept is not very pretty. It's a decimal. But if I go up to my y-intercept, that one works. So I'm going to use that one. You don't have to use your x and y. You could use something in between if you wanted to. I just think those are the easiest since they just click for you. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, plot a point, and do as close of a straight line as I can. But like I said, it's just a sketch. If you wanted perfect points, you would type it into Desmos anyway. Don't forget to label what your solution was. I know we graphed it, but I didn't write it down. My solution was -5, -7. We have any questions so far? Okay, so page number 2. What is the solution of x plus 3y equals -15 and y equals -7? If I gave you a question like that, what would you do with it? Just plug it into Desmos, right? It didn't even give you a graph to try to do it by yourself. It wants you to plug it into Desmos. So go ahead and clear out what you had and type in your new stuff. But remember, please do not make mistakes, because if you do, you will get the wrong answer. So always double check to make sure you typed in everything perfectly. That's the only responsibility you have. Desmos does everything else for you. So, once you have those graphed, raise your hand if you have a solution for me. I'll kind of wait until multiple hands are in the air, so I know we've all had enough time to type it in. We've all had enough time to look for our solution. Evan, you sleepy back there?
I just
Want this on your desk?
Yes, please, thank you. Girls, we good? Leah, Isabel, are you good? You have answers? What are we struggling with? You guys are looking at each other like I don't have what you have. That's a Y.
This is one.
Oh, you're not plugging in Chuggy. This is like equation 1, this is equation 2. 2 lines. So type it in like how I have on mine. See how I typed it in? So 2 lines. I see what you did. Okay. One of you who had your hand up, what's my solution here, Chandler?
6, -7.
6, -7, and I clicked on it on my screen here. Is that what the rest of you got as well?
Yep.
Like I said, the only way you don't is if you typed it in wrong. Okay, so if you ever don't get these answers, double check what you typed in. All right, do number 4. Number 4 has an f of x and a fraction. Who cares? It's still an equation, and Desmos is going to graph it for you. The only thing is, with the fraction, make sure you come out of the fraction to do the +2. Do not leave it in your denominator, otherwise it will not give you the same thing. So it must look exactly as it looks on your paper. Give me a thumbs up when you're ready. Okay, if you're struggling, if you click on the 2 lines, see how they change colors?
Yeah.
That's because it's the same line. I know when you're typing things in, if you're not looking at your screen, you may miss it. Like this morning, some kid was like, I typed it in, but I didn't see where it went. They were like zooming out. They're on top of each other. Okay, so again, if you click between the lines, it'll show you that it's the same line. So, if it's the exact same line, is it no solution or infinite solution? Because how many points do they have in common? All of them, so many, infinite. Now, when we're doing infinite solution, that grade point that I clicked right there, 0, 2, is that an answer?
Yeah.
Is it on the line?
Yeah.
Yeah, so it's an answer. What about this one?
Yeah.
Yeah? What about this decimal right here?
Yeah.
Yeah.
Yeah? What about this point down here? No, it has to be on the line. It can't just be any point you want. Does that make sense? Okay. All right, let's go on to this last one. Well, not the last one. I lied. This next one. A system of equations is given, and it gives you the first system. Which system of equations has the same solution as the given? So same solution means the same answer, the same intersection point. So let's type in the first one. So your first one is x plus 3y equals 1. And your second one is negative 2x minus y equals negative 2. And what is the solution to the original set that you have? 1, 0. So I'm going to click it. I'm going to write it right up here so that way I know what I'm looking for when I type in my multiple choice. Now for your multiple choice, what I would do, you see the colored circles? Instead of closing them in case you need them later, I would just turn the colored circle off so the graph disappears. But now, in case you mess up, you don't have to type everything in again, okay? So just go ahead and go to your next line. Start typing in all your multiple choice. If it doesn't work, you can either delete it or just remove the color. So that way you don't have to type something in twice if you need to redo something. Take a few minutes to do that on your own. Thumbs up if you've had enough time to get your answer. You can put them down for a minute. I'll give you 1 minute, then we're going to go over this one. Okay, I will say when I was walking around the room, there were different answers and we're going to talk about it. But how many of you got A, B, C, D?
Bunch of liars.
Oh, there are some liars because I definitely saw things other than D on your paper. But we will talk about it. So I put option D in first. D is the correct answer. That is the one that crosses at 1, 0. But for those of you who got tricked, like this morning, the big common one that people clicked was B, so I typed that in as well. So this is this second one right here. What they did is they accidentally clicked on the x-intercept of the purple line. When you're zoomed out kind of far, that's easy to do because all of your intercepts end up being pretty points. So Desmos gives them to you. So it's very easy to click on intercepts versus the intersection. So see when I'm zoomed out how close those 2 points are to each other? So that's probably what happened if you made a mistake the first go around, okay? So the one thing that I do just to say, let's be sure, is just zoom in a couple of times, make sure you're actually clicking where the lines cross each other and not where one line just crosses an x-axis, because that doesn't mean anything to me. Does that make sense? So just be super careful because it is an easy question, but if we accidentally click on the wrong thing, we could miss it. All right? Okay. The next one. The EOC loves to give you easy questions, but word them very challenging. And that is a good example of this one right here. The equations of two functions are given, and it gives you an f of x and a g of x. And then what value of x makes the equation f of x equal to g of x true? Now, if this were a test at the end of the year and we weren't in the middle of our systems unit, you may not recognize this as a system. You would just be like, what the heck is it trying to ask me? So if you are ever given a question like this, what would you do if you were stuck? Anytime you are given an equation, just plug it into Desmos and see what the graph looks like. I promise you, you may end up getting lucky, and even if you don't know what you're doing, you may be able to guess correctly. So type in your original, f of x equals 3x plus 4, and then g of x, which, by the way, what do f of x and g of x stand for? They're just a fancy way of writing, what did you say? Y. So you could put y instead of that if you want to, but I'm just going to let it be. Keep it as is. Okay, so even if I had no idea what I was doing on this test and I typed it in, what do you think you would click on, just common sense? Probably where they intersect, right? So now their solution to that system is 1.5 and 8.5. I'm going to write that up here. But if I look at my question, what value of x makes them equal to each other? Well, first, if they're equal to each other, they need to be the same. So yes, that intersection is correct. They are the same where they cross. There's no other points where they're the same. But what is the x value there? 1.5. So it didn't want the whole solution. It only wanted the x value. So reading what the question is actually asking for is very, very important. Okay? Notice how your response box was x equals versus, I'll show you what an ordered pair box looks like on the EOC. See this one? See how it has parenthesis, comma, parenthesis, and there's two boxes? That's what it'll look like if you want an ordered pair. So if it's not an ordered pair and it's just a box, I'm not guaranteeing it, but they probably just want something else. And this one did. It only wanted the x value. Okay? All right. We're not quite done yet. Sorry. I know it's a long day, but we're almost there. So linear quadratic systems.